In this video, I'm going to show you how to graph an exponential function like this one. I think we should start by just graphing the parent function, this part of it. We'll do the +2 later. In fact, our very first step, we're only going to graph the y equals 2 to the x power. So let me show you what I mean. So let's make our table of values. Okay, when we do logarithms, we start with the y values. But we don't do that for exponential functions. When we do exponential functions, and right now we're just thinking y equals 2 to the x power, we start with the x values like we have since you were little. So we'll start always with the same x values, -2, -1, 0, 1, and 2. For the y values, we can do 2 to the x power. So that means, 2 to the second power, 2 to the 1 power, 2 to the 0 power, 2 to the -1 power, and 2 to the -2 power. I recommend that you start at the bottom of the chart and go up. 2 squared is 4. 2 to the 1 power is 2. Anything to the 0 power is 1. These last two will just be the reciprocals of the bottom two. So this will be 1/2 and 1/4. Okay, so that's the parent function. Now, I want to go ahead and do this transformation on the chart. I won't do the +2 on the chart, but I'm going to do the 5 on the chart. Okay, this 5 is affecting the y values, a vertical stretch. So when I have a number in the front like that, I'm going to make a new y column. Yes?
In what case would it be affecting the x? Like, just what would that look like?
If there was like a 5 here, like right on the x,
okay,
that would actually be a horizontal compression though. So that would be a new x column, but it would be 1/5. Because everything on the x is going to be the opposite of the way it looks.
Okay.
So if there were a 5 there, that's actually a compression by 1/5. If there was if I had 2 to the 1/3 x power, if I had a 1/3 up in the exponent like that, that would affect the x's, but that will actually be a horizontal stretch. So I would do ×3. I would do 3 times all the x's if it was 1/3.
So when it's not directly on the x, it's to the y, and it's like the same.
And it's normal,
okay,
yes. And this thing for exponential functions, that's very rare, and I would be surprised if there was one on the test.
Okay, so most of the time it'll be like.
Most of the time for these functions, it'll just be the y's.
Okay.
Okay, so because of the 5, I'm going to do 5 times all the y's. So that's going to make this 5/4 and 5/2 and 5 and 10 and 20. 5/4 is what, like 1 point something? 1 point, what is it? 2.5? Okay, so I'll call it 1.3. And this is 2.5. I make these decimals just for graphing reasons. Okay, so I'm going to throw out the old y column because I have a new y column now. So I'm going to plot these points, but I'm not going to connect them because they are not the final answer because I haven't done the +2 yet. I will do that on the graph itself.
So you need this one graph.
Yeah.
Okay.
Okay, yeah. Basically, you graph everything except for the pluses and minuses, and then just do the pluses and minuses on the graph paper.
Okay.
So I'm going to do, so I have -2, 1.3. So that's -2, 1.3 would be like right here. Let's see, -1, 2.5. It's right there. 0, 5 is right here. 1, 10 is right there. And 2, 20 is right there. So we've done everything except for the +2 on the end. So that's what I'm going to do now. This +2 means that I need to shift everything up 2. That includes the horizontal asymptote.
So it doesn't reverse because it's going to the y again.
Correct,
Okay,
correct.
would there ever be like a x minus, like will we have like x minus 1 and then we have to...
Yeah, that's possible. That's
Okay.
not so
And then it
unlikely. There could be like an x minus 1 up there.
And then we would just add 1.
And then we would move everything to the right by 1.
Okay.
Yeah, that could show up on the test.
Okay.
Because we're going up by 2.
And we would do that. Like we would still graph everything like we have and then just do it. Okay.
Exactly.
Got it.
But don't forget about the asymptote. For exponential functions, there's a horizontal asymptote that usually is at 0, the x-axis. Because of this up 2 business, yeah, the new asymptote is going to be here at 2. Okay, at y equals 2. All right, and you should graph that as a dotted line like I did. So I'll just move everything up 2. Even though this one is like off the graph, I'm just going to estimate as best I can. And up 2, up 2, up 2. And up 2. Wait, this one is off.
And then that one you connect.
And this one I connect, and I respect the asymptote.
Right.
Okay, so it should be approaching the asymptote, and just try to draw a smooth curve through all these points. Okay, so your graph should look something like this. Now, on this particular problem, I did not ask you for the x-intercept or the y-intercept, but I might.
Wait, it says identify the domain range intercepts x and y and s.
Okay, I guess I did. Let's do all that stuff. Wonder, does it say that for the logarithm functions too? Okay. Might have to go back and edit the video I did before. So we need the domain range, x and y intercepts, and the asymptote. So let's do that. So the domain is how far it goes from left to right. So that's -∞ to +∞. The range, all right, that's how far it goes from bottom to top.
So 2 to infinity.
So 2 to infinity with a round parentheses. Okay, so now we need the x and y intercepts. What do you think about the x-intercept?
Is there an x-intercept?
Right, there won't be, because it doesn't touch, it doesn't go down that far. So for the x-intercept, we're just going to say none. And then the y-intercept. So remember, for the y-intercept, we let x equal 0. So I'm just going to look back at the original problem, and I will let x equal 0. So if I plug in 0 right here,
It's going to become
okay, that's going to become 1. So that really means I'm going to have y equals 5. It's 5 times 1 is 5,
2, so 7.
plus 2, so 7. Okay, so that's why the y-intercept is going to be 0, 7. All right, is that all we were asked for?
And then asymptote, but that should be y equals 2.
That, and yes, asymptote. Okay, is just going to be y equals 2.
Okay. And then